Hi. Second to last video. This video I'm hoping to make fairly short, like the other two, maybe even shorter. Here we go. So solving special systems. So we have systems that have no solution. We have systems that have infinite solutions. So those were our last two videos that we did. And now we are going to be looking at our last scenario. And it's one that we've been dealing with for the last like 4 lessons or like 3 lessons, I guess, like 6.1 through 6.3. So this is one that you should be familiar with. Let's do this. All right, so as we solve this system, again, we can use whatever method we want to unless it's specifically specified. I don't care if you use substitution, graphing, or elimination. Use one. Do whatever works best for you. Understand that graphing can be messy if you are not being careful, and if it turns out that the intersection is off your graph, it can be messy. Either way, I'm going to solve this using substitution because they are all, or both of these are set up for in y equals form, meaning I can substitute everything on this side with everything on this side, and I can set them equal to each other. So I can say 2 times x minus 1 is equal to x plus 1, and I can solve for x, right? So distribute, I get 2x minus 2 is equal to x plus 1. I'm going to subtract x from both sides. I get x minus 2 is equal to 1. I'm going to add 2 to both sides. I get x is equal to 3. I actually got a number this time. The x didn't cancel out. I didn't end up with a statement that's false or anything like that. I actually got a value. So I'm going to start writing an ordered pair. So x is equal to 3. So now I'm going to put that 3 into one of these two equations. I'm going to put it in the bottom equation because it's a little bit easier. I won't have to deal with the parentheses. 3 plus 1 equals 4. So this system didn't end up having something that was a false statement like 0 is equal to 21 or a true statement of 0 equals 0. It truly had one solution, a single point that came out of this. So one solution is our last and final, let's make that S capitalized so it's like all the others, is our last and final situation that we're looking at. So let's look and see what this particular graph looks like because we've done it with all the others. I'm going to set this up so I hopefully can see it. Oh my gosh, this is so messy. Thank you for bearing with me. All right, so this first equation, x plus 1, so y-intercept of 1, I'm going to up 1 to the right one, up 1 to the right one for my slope, down 1 to the left one, down 1 to the left one for my slope. If I look at, so I can create this line, this second line, y equals 2 times x minus 1. I need to actually simplify this. I need to distribute this 2 in here. So I get 2x minus 2. It means I'm down here at negative 2, up 2 to the right one, up 2 to the right one, up 2 to the right one. Look at that. I just found the intersection point. And again, it's at 3, 4. So we can look at these 3 different solutions or 3 different possibilities for the solutions and know that in any sort of system, we are going to have 3 possibilities. You could end up with a situation where you have no solution, where you end up with an answer of like 0 equals 21, which we know is false. Or we could have infinite solutions where we get an answer of like 2 equals 2, which we know is very true. That means we have the same line. And so we have parallel lines, same lines, or one solution where we truly have one intersection where we have 2 lines that cross each other. Kind of cool. One more video after this, and we're going to be talking about categorizing systems in this last video. It can be a little confusing. However, hopefully I can explain it in a way that makes sense and allows you to remember it. If you don't, this is one of those things that you would want to put on your note card because it's not something that's necessarily tested very often. It's not even going to be on the final in a couple of weeks, but at the same time, it could be of benefit in the future if you ever get into more math theory classes and things like that. Either way, thank you for watching. It was nice seeing you. Bye.